range equals high value minus low value. To find your standard deviation, you're welcome to do that on a calculator as well, on both your homeworks and your tests. To do it by hand, first list all your x values, and then sum of the x's, sum of your data values. You add them up. 654. Then you square each of these values and sum them. Once you have the sum of your data values, sum of x, and the sum of your data values squared, sum of x squared, you're ready to start work with the standard deviation. First, write down the formula for standard deviation. You're using the non-grouped formula. I have color-coded my formula so that you can see easily which piece goes where. The one thing that I didn't do in my chart is to tell you what n is. How do you find n? You count up all your data values. So in our case, we have 9. Our n is 9. So now I go through and I just sub things in. I put the 9 where the n is. I put the 47,596 where the sum of the x squared is, and so on. I'll color code so that you can see how to do this. But the only way to really get the hang of it is to practice it yourself over and over. If you need to do it with a tutor, do so. So I've subbed in all the numbers in their correct spots. Now we just have to evaluate this ugly thing. You can just put it in your calculator, especially if you have one of the teal calculators. Otherwise, what I like to do is evaluate the top row using a calculator. I can see the bottom is 9 times 8, 72. So that it looks like this. Then in my calculator, I evaluate this fraction, 648 divided by 72, making sure to keep my square root sign, because I haven't done the square root yet. 648 divided by 72 is 9. Then the square root of 9 is 3. So 3 is my S, my standard deviation. Now how do I find my variance from that? Well, the variance is just the standard deviation squared. So I can square that number, or if I just go one step backwards, I will also find it. Again, you are welcome to put these data values in your calculator and find the standard deviation. That way you will also get these numbers, the sum of the x's, the sum of the x squareds, on your calculator. First, I need to find xm, the midpoint of each class. So to do that, I average the upper and lower limits. So 8 plus 12, enter, divided by 2. 13 plus 17, enter, divided by 2. And so on. Then I do f times xm, the frequency times the midpoint. Once you've done that, add your column to add up the frequency times the midpoints. You get 590. Now, frequency times midpoint squared. Again, I just put this in my calculator. 3 times 10 squared. Be careful. You cannot just square this number. That won't work. Now, to get the sum of the f times xm squared, I'm just going to add up the numbers in that column. 12,350. Another thing I need for my formula is n. To find the n, the total number of data values, you just add up the frequencies. So I add up the numbers in the frequency column. I get n is 30. Next, I'll go to find my formula for standard deviation of a grouped sample. I think it's easier when I put the colors in to see which things have to be subbed out and what goes in their place. Once you do a few of these and actually practice doing them too, you get kind of to know the pattern. That this number is the first one that goes in. And then this number you put here, but you end up squaring it. You have to make very sure to have all of these pieces in your formula or your problem won't work out. So you can see where each of the numbers subs in. The n, the sum of the f times xm squared, and the sum of f times xm. That number is going to end up getting squared. Now we just need to evaluate this. I like to do the top and the bottom. So I plug that whole top row into my calculator. And then 30 times 29. Then I divide these two numbers. We are going to end up rounding to one decimal place, but I always make sure to include more than that in my work and then round at the end. Then I take the square root of 25.747 and I get this, which I will then round to one decimal place. There is my S, my standard deviation. The variation is that squared, or you can just go back a step, 25.7. Again, you are welcome to use a calculator. In that case, you can just fill in this, and your standard deviation without filling in your table. If you are in Connie's class, you did not have numbers 3 and 4 for your homework. On some of these problems with bigger numbers, I would be tempted to just use my calculator because the numbers get pretty big. But I will show you how to go through and do it by hand if you don't want to do that. First, enter in your data values, square them, find the sum of the x's and the sum of the x squareds. Phew, that was a lot of work. Like I said, big numbers here. The next thing we're going to need for our formula is we have to know what n is, the total number of data values that we have. So this is a non-group sample, no frequency, so we just count them up. 2, 4, 6, 8, 10. There are 10 items, 10 data values. Then I'll write down the formula. Again, I think the colors help you to see which things are going to go into which spot. It also helps to make sure that you don't forget anything. If you forget one of the squareds or forget the square root, it's going to screw up your whole thing. So now sub your numbers in. So I've subbed in my sum of the x squareds, my sum of the x's, which I'm going to have to square, and my 10 for n. In my calculator, I evaluate the top row. And 10 times 9 is 90. Then I evaluate that fraction. Remember, I haven't done the square root yet, so I still write it. And then I take the square root of that number. I'm going to round that to one decimal place, so I get 44, that's 4. For my standard deviation. Your variance would be this number. Range, high minus low, 160. Again, I would probably do that one on a calculator. I will need to copy my frequencies from the book and find my midpoints. Again, to find the midpoint, you take the class limits, add them, and divide by 2. So 13 plus 19, enter, divide by 2. You should get 16. So I will fill in my frequencies and midpoints. Then I'll multiply my frequencies times my midpoints to get the F times XM column. And I'll times my frequency times the midpoint squared. Remember to do that as a separate calculation to get that column. Double check the last column. It's the same as mine. That's sometimes where people make mistakes. If you have those wrong, double check this. A lot of people do this and it's wrong. You can't just take the 32 and square it and put your answer here. You have to actually do the frequency, 16, times the midpoint, 32 squared, in your calculator. Next, I will find the sum of this column by adding up these numbers, or by looking on my calculator. I would do a calculator for this problem. This guy has a lot of busy work. And I'll sum this column. The other thing I'll need for my formula is the n, the total number. So I add up my frequency, and I get 35. Next, I will write down my formula and sub the numbers in. Next, I will sub my values in that I have figured out in my table. Then I will evaluate. I like to plug the top row into my calculator. And 35 times 34. Then I do this division without yet doing the square root, so I'll still have the square root. Remember, don't round yet. Round at the end. So when I take the square root, I get 11.5575, which gets rounded. Now we round to one decimal place, 11.6. That is my standard deviation. My variance, square that or go backwards here, 133.6. What would you put for the range? I would just take my high number minus my low number, which would be 55. To find if something is more variable, you use the coefficient of variation. So go to your formula sheet and find the formula for that. C bar is the standard deviation divided by the mean, S divided by X bar, times 100, and your answer will come out as a percent. So we'll do the construction workers first. Standard deviation was 2.3 divided by X bar, mean, the mean was 11, times by 100. Put that in your calculator, round to the nearest tenth of a percent, 20.9%. Factory workers, days missed. Again, use your formula. S divided by X bar times 100. S, standard deviation, is 1.8. X bar, mean, was 8, times 100 to turn it into a percent. I plug that into my calculator, round it to the nearest tenth of a percent, 22.5%. Which was more variable? The factory worker had a higher percentage, so they're more variable. Problem number 6. You want 75% of your data values, the top 75% of your data values. Chebyshev's theorem tells us that the top 75% of our data values are plus or minus, or within 2 standard deviations, so 2 times the standard deviation from the mean. So we take our mean, And we add 2 standard deviations. So we add 2 times the standard deviation was 48,500. So we add 2 standard deviations. That'll give us our upper value, upper bound, for this 75%. And then we subtract off 2 standard deviations, so 2 times the standard deviation. So we know that 75% of our data values will fall in between 149,300 and 343,300. Number 7. Find the z-score formula from your green sheet. The z-score is the data value minus the mean divided by the standard deviation. In our problem, number 7, the mean, x bar, was 72, and the standard deviation was 5. So the x, again, means our score or our data value. So A, our score was 79. Punch it in on your calculator. Make sure to do the top, hit enter, and then divide by 5. 0.6 is the z-score. So you're less than 1 standard deviation above the mean. Oops, this is a 76. Mean should be 76, not 72. B, for the raw score of 70. Take your data value minus the mean, hit enter, divide by 5. A negative z-score means that your score was below the mean. A little more than 1 standard deviation below the mean. So a little more than 5 below the mean. And you can see that. Part C, score of 88. .4. 2.4 standard deviations above the mean. Part D. Ooh, he scored kind of low. So I can guess already that he's going to have a negative z-score. So he's below the mean. He's 2.2 standard deviations below the mean. Z-score of negative 2.2. E. Raw score of 77. Well, I bet that z-score is going to be really close to 0. Because 0, having a z-score of 0 means having the value of the mean. So I'm 1 above the mean, so I'm going to have a z-score that's really close to 0. So my z-score, 0.2. Raw scores. Our mean, in this case, was 54,166, and our standard deviation was 10,200. So I want to find if the z-score was 2, what was your original data value? Well, if I know that my z-score is 2, that means I'm 2 standard deviations above the mean. So you take your mean, and you add on 2 standard deviations, or 2 times 10,200. Part B. If our z-score is 1, negative 1, what's your original raw score, your data value? Well, let's see. I know my mean is 54,166. And I know I'm 1 standard deviation below that. Well, a standard deviation is 10,200, so I subtract off 10,200. C, if my z-score is 0. If your z-score is 0, it means you're right at the mean. B, if your z-score is 2.5. That means you're 2.5 standard deviations above the mean. So you take the mean, and you add on 2.5 times the standard deviation. E, z-score of negative 1.6. You're 1.6 standard deviations below the mean. So you take your mean and subtract off 1.6 standard deviations, or 1.6 times the standard deviation. Find the z-scores for each raw score. So the raw scores were 3.2, 630, 43. For part A, your mean was 4.6, and standard deviation was 1.5. So you just do x minus x bar over s. Again, x is your data value, your raw score, 3.2. X bar is the mean, 4.6. S, standard deviation, is 1.5. So you just plug that into your formula. 3.2 minus 4.6. Our raw score is below average, so we're going to have a negative z-score. Negative 0.93 repeating. We'll round to negative 0.93. So I'm almost 1 standard deviation below the mean. And you do the same for the next two. Again, I'm just plugging into a formula. My data value minus the mean divided by the standard deviation. So this part A was 0.93 below the mean, standard deviation is below the mean, z-score. Z-score of negative 0.85 means negative 0.85 standard deviations below the mean. And C, z-score of negative 1.4 means 1.4 standard deviations below the mean. Which is the highest score? The highest relative position? This one. That's the largest number of those three numbers. Number 9. When you are ever asked which is more variable, that is a hint that you need to use the coefficient of variation, or CVAR. CVAR lets you compare the variation on two problems that have different numbers associated with them. So you look on your sheet, your green sheet, your formula sheet, and you see that CVAR is figured by taking the standard deviation divided by the mean, timesing by 100. So we will do our textbooks. Standard deviation was 5, mean was 16, times 100 to turn it into a percent, and you get 31.25. We will round that to the nearest tenth of a percent. Then we'll do the professors' ages. Standard deviation was 8. Age was 43 times 100. That's what my formula says. And I get 18.6%. So which is more variable? The one with the higher C-bar is more variable. My first step to find the 5-number summary by hand is to order my data. Your calculator, if you do one variable stats, will also give you a 5-number summary, so you can do it that way if you want to. The 5-number summary consists of the low, quartile 1, the median, quartile 3, and the high. Basically what these do is just split your data into fourths. So your low and your high, we've already got that, 28 and 39. And then next I do the median. So the median I just count until I find the middle number. The middle number here is 35, so that's my median. So then Q1, that's your bottom quarter of your data. So you find the median of the bottom half. So here's my bottom half. The middle number is 30, so my median will be 30. Q3 is the top 3/4 of the data, so 1/4, 2/4, 3/4. So I want the median of the top half. So the middle number of my top half is 37. So there is my 5-number summary. So when you're asked for 5-number summary, that's what you want. Interquartile range. You'll find this on your sheet under IQR. It will tell you that the formula for interquartile range, or IQR, is Q3 minus Q1. What's the range that takes up the middle half of your data? So we're looking for this middle part. What's the range of values there? So our Q3 was 37 minus 30 is 7. Our interquartile range is 7. To make a box plot, you first need an axis, just a one-dimensional x-axis. I numbered by 2s. You can number whatever you think is appropriate so that your data is spread out, but your low and your high are both accommodated. So to make a box plot, or a box and whiskers plot, you want a box that goes from Q1 to Q3 with a line at the median. So Q1 was 30, that's right here. Q3 was 37, so you want a rectangular box that shows those data values with a line at your median, so a line at 35. And then you do whiskers out to your high and your low. So my low went down to 28, my high up to 39. And then I like to label these points. And there is a box plot, sometimes called a box and whisker plot.